Hello students and welcome to online lecture. This is the lecture number 7 and this is about the logic gates, and today we are going to discuss about NOR gate. Previously we have studied about NAND gate and OR gate, AND gate, NOT gate. So basically now we are going for little advanced form, like the basic forms are AND gate, OR gate and NOT gate. Now this is a NOR gate. So if we go to the next, this is the NOT gate. If you can see here, this is a basically shape of the NOR gate. There is a little difference between AND gate and NOR gate. The difference is, first thing is the shape. This is a little tailed one, and it is a combination of NOT gate and OR gate. As we know, what is OR gate? The OR gate is actually whenever either A or B is high voltage, so the output X will be high voltage. And in NOT gate, it is whenever the high voltage is converted into low voltage and low voltage is converted into high voltage. Exactly. The output in NOT gates is the combination of NOT gate and OR gate. The output X will be high voltage unless both inputs are high voltage. If either input is high voltage, the output will be low voltage. This means that X always be 0 unless A and B are 0. As you can see the truth table here. Now let me explain it. Here is A, as you can see here A, and this is B, input B, and there is X, the output X. If we can say that there is the combination of two gates, let me draw it. There is, sorry for my drawing, but I can imagine that you can understand well. And this is basically the combination of two gates. This is OR gate and this NOT gate. This is, we can assume as A, and this is B, and this is a C here, and the final output is X here. So when we have both are 0 and 0, as we know that both are low voltage, so there will be low voltage, and here the low voltage is converted into high voltage. That's what this statement tells about. So I'm going to draw this one. As we know that whenever there is 0, here it is 0, here it is 0, so both are 0, and here in an OR gate it's 0, because we know the previous lessons that in OR gate when there is low voltage either A or B is, so the output will be low voltage. But here it is a NOT gate, so as I told you that the low voltage is converted into high voltage, so the answer is 1 here. Now here is 0, as you can see here is a 0 here, and B is 1, so I can write this as a 0, and here it is 1, and we know that in OR gate either A or B is high voltage, so here it is low voltage, here it is high voltage, so when it passes through it, here it is high voltage, but here is an vertex, yani NOT gate, so 1 is converted into 0. That's what it tells about. And vice versa, if this is 1, if this is 1 and this is 0, so when it passes through it, it's 1, and when 1 is passes through NOT gate, it becomes a 0 here, so that's why we can call it 0. Now the last statement, 1, 1 and 0. How it becomes, now let me demonstrate this as well. Here it is, as it is high voltage here and high voltage here. And OR gate, whenever there is high voltage at A, high voltage at B, the output will be high voltage. So when high voltage passes through NOT gate, it becomes 0. That's what it is. Now let's see in the simulator, which is called logically, and this is written in the logical notation is x yani output is equal to a, and this is NOR gate is used. B, our boolean is x is equal to a plus b. Now let us see in the logically how it works. This is a basically simulator. As you can see, you can use the NOR gate here, or if you want to understand it, I can get it a OR gate and a NOT gate. So I'm getting this and this here, and for output I need a light bulb here and two toggle switches. That is, if this is off, that means it's 0. When I turn it on, it's 1. So toggle switch here. Now I have to connect all of these together. Here is A, this is B, this is C, and this is finally called our X. Now whenever both are 0, the 0 into 0 is 0 here, and when 0 passes through this one, it becomes 1. Now what will happen is, if this is 1 and this is 0, 1 and 0, so whenever it is passes through it, so it becomes 1 and 1 becomes 0 here. Now let's see. You had seen this, that it's 1, now it's 0. 1 and this is 0. Whenever 1 and 0, here it is 1 and 1 passes to NOT gate, it converts into 0. So that's why it's here. Vice versa, we are doing this as well. As you can see, the result is the same. If what will happen if I turn both them on? 1 into 1. 1 is high voltage, it is high voltage, and it's high voltage as well, but it is converted into 0. So this is what the NOT gate was. As you can see here, this is the truth table. I hope that you can understand well. If you have any questions, you can ask me. I hope that you will enjoy my lessons. Thank you. Take care.